position of rear. Hello friends, have you understood this? In a circular queue, if front is at next position of rear, then we can say it is full. Same as no, अरे ये linear queue जैसा नहीं है. This is not a linear queue. ये circular manner में increment हो रहे हैं values. For one, in linear queue, values of front and rear are going in a linear fashion. Whereas in a circular queue, it is in a circular manner. Diagram से आपको समझ रहा है? Hello guys, are you getting what I'm saying? Are you getting what I'm saying? Right? Okay. So pay attention. Have you understood this condition? आपको ये condition समझ में आया क्या? Q full condition. Hello friends. अभी मुझे बाकी की possibilities मत पूछो. As of now, just please tell me, have you understood this condition? Q full condition. So if circular Q, if front is at next position of rear, then we can say Q is full. Right? It means, can we say like this? If front is equal to rear plus 1. Hello friends. Can we say like this? Can we say like this? If front is equal to rear plus 1, right? But don't you think guys, sir, this expression will fail. ये expression से इसका मतलब अगर LHS equal to RHS तो हम बोलेंगे Q is full. But this expression will fail for these values. Rear का value क्या है? Rear का value 4. 4 plus 1 is 5. 4 plus 1 is 5. And front का value 0. So is 0 is equal to 5? Is 0 is equal to 5? No. And hence we will not want to use this condition as it is. हम लोग यहाँ पे एक logic use करने वाले हैं, modular size. So we will want to use one more logic over here, modular size. Right? Sir, ये कैसे होगा देखो, pay attention. Now for value of rear is equal to 0. Sir, rear का next position, 0 का next position. Hello friends, 0 का next position पता मुझे क्या है? 1. So is front is at next position of rear. Next position of rear. Yes. So what it means? Q is full. Right? It means, pay attention. Sir, for this condition क्या आना चाहिए? LHS must be equal to RHS. Hello guys, LHS must be equal to RHS. Sir, वो कैसे? Please check. Front का value कोई बताए मुझे क्या है यहाँ पे? Front का value 1. तो यहाँ पे front का value 1 replace करते हैं. Equal to. Rear का value क्या है? Rear का value 0. Right? So here we'll write 0. 0 plus 1 mod. So what is the value of size? 5. Array का size 5 है ना? Right? And hence we can go to the next step. Yes. 0 plus 1 is what? 0 plus 1 is 1. 1 mod 5. Hello friends, 1 mod 5. 1 mod 5 answer is 1. Right? Is LHS equal to RHS? LHS equal to RHS. It means, is it showing Q is full? Hello friends, for these values, is this expression is showing Q is full? Yes. For these values, expression shows that LHS equal to RHS and Q is full. Right? Now we are moving to the next value. Yes, pay attention. Very important. Sir, if value of rear is 1, what is next position of 1? 1 का next position क्या होता है? 2. Very good. Next position of 1 is 2. So if we replace value of front as 2, and value of rear as, if we replace value of front as 2 and value of rear as 1, yes, 1 plus 1 is what? 2. 2 mod 5. 2 mod 5 answer is 2. Is LHS equal to RHS? Yes. It means again it is showing that Q is full. Hello friends, are you with me? Now for another possible values, if value of rear is 2, what is next position of 2? 2 का next position 3. Right? So can we say front is at next position of rear? Yes. तो सर इसके लिए भी क्या आना चाहिए? For these values as well, it should give us LHS equal to RHS, which indicates Q is full. So if we replace value of, yes, if we replace values of, front is equal to 3, right? And rear equal to, अब लोग rear का value replace करेंगे 2, right? So 2 plus 1, result is 3. So 3 mod 5, answer is 3. Is 3 is equal to 3? Yes. So LHS equal to RHS, which indicates Q is full. Right? Now for next value, if value of rear is 3 का next position 4. Very good. So for this, again it should give us LHS equal to RHS. So if we replace the value as 4 and 4, right? And if we replace value of rear as 3 plus 1, 3 plus 1 क्या आएगा answer? 4. And what is the result of 4 mod 5? Result of 4 mod 5 is 4. So is LHS equal to RHS? Yes. And hence in this case as well, we are getting Q as full. Right? Now very interesting guys, pay attention. So but what if value of rear is 0? Sorry, 0 नहीं यहाँ पे 4 ना. Value of rear is 4. So what is the next position of 4? Next position of 4 is what? 0, right? And value of front is 0. So can we say front is at next position of rear? Yes. So for these values as well, it should give us LHS equal to RHS. So if you replace the value of front as 0, 0 and 0, and now please note guys here, if you replace value of rear as 4, 4 plus 1 is 5. 5 mod 5, answer is 0. Are we getting LHS equal to RHS? Yes, and hence here we can say Q is full. Hello friends, are you getting? Right? And hence this is a condition we can write for Q full. हम ये Q full के लिए ये यहाँ पे condition लिख सकते हैं that if front is equal to rear plus 1 mod sides, we can say Q is full. So yes, if front is at next position of rear, we can say circular Q is full. I hope you people have understood this. Hello guys, have you understood this? Right? Okay, now pay attention. अब ये increment का देखते हैं. Increment का. Say, please check guys. When we say rear plus plus, do you people know when we say rear plus plus how it will get resolved? When we say rear plus plus, how it gets resolved? It gets resolved like this. Rear is equal to rear plus 1. Hello friends, do you agree with this? So when we say rear plus plus, it gets resolved like this. Rear is equal to rear plus 1. Right? Now, we'll not want to use rear plus plus, this expression. हम लोग इंक्रीमेंट करने के लिए एक्सप्रेशन ये यूज नहीं करेंगे. We'll use rear is equal to into bracket rear plus 1 mod sides. Hello friends, are you getting what I'm saying? So to increment value of rear by 1, we'll use this statement. Sir, is this statement will work? Yes, please check. For value of rear equal to 0, and if we say incremented by 1, 0 का क्या होना चाहिए friends? If currently value of rear is 0, and if we say incremented by 1, it should become. Hello friends, in our case, if value of rear is 0, if we say incremented by 1, it should become 1. If it is 1, it should become 2. If it is 2, it should become 3. If it is 3, it should become 4. If it is 4, it should become 0 and not 5. अरे हमें यही achieve करना है ना, right? And hence we're going to use this expression for increment, right? Pay attention how it works now. Pay attention how it works now, right? So 0 का क्या होना चाहिए? 0 का होना चाहिए 1, right? So if we replace the value over here, yes, rear का value 0 plus 1 mod 5. 1 mod 5. अब बोलो क्या है आंसर? 1 mod 5. 1 mod 5 answer is 1. So is value of rear is getting incremented by 1. 0 का 1 हो रहा है क्या? Is value of rear is getting incremented by 1 by this expression? Yes. Right? Now, for value of rear equal to 1, for value of rear is equal to 1, after incrementing it should become 2. Very good. So if we use this expression, right, same expression, तो सर यहाँ पे instead of rear का value replace करेंगे 1. 1 plus 1. 1 plus 1, answer is 2. 2 mod 5, answer is 2. So is it getting incremented by 1? Yes, it is getting incremented by 1. So for value of rear is equal to 2, and if we say incremented by 1, it should become 3. So if we replace the value of rear by 2 over here, 2 plus 1, 3. So 3 mod 5 is 3. Similarly, for if value of rear is 3, and if we say incremented by 1, it should become, बोलो क्या होना चाहिए? वो 4 होना चाहिए, right? And very interesting guys, if it is 4, and if we say increment it by 1, yes, 4 plus 1 is 5. 5 mod 5, 0. Hello friends, have you achieved this? Have we achieved this? Sir, अगर 4 है तो 4 का increment करने के बाद 0 हो रहा है क्या? Yes. लेकिन उसके लिए हमें क्या करना पड़ेगा? We need to use this expression. And hence let me write over here. So increment करना है मतलब क्या करना है? Say rear is equal to into bracket rear plus 1 mod size. I hope you people have understood this. And here we are finished with NQ operation. सब front के लिए भी same use करेंगे. When we say increment the value of front by 1, yes, so इसका मतलब यहाँ पे भी क्या करेंगे हम लोग? Yes, front is equal to front plus 1 mod size. Hello guys, are you getting what I'm saying? So when we say increment the value of front by 1, again we're going to use same statement, front equal to front plus 1 mod size, right? Okay, but sir, pay attention, we have not yet finished with DQ operation. And QMD condition. अभी वो देखते हैं, right? Okay, now currently, yes, what is the value of rear guys? What is value of rear? 1. what is value of front? Value of front is 2, right? Now if we apply DQ operation, step number 1, check Q is not empty. So by diagram, is Q is empty? By diagram, is Q is empty? No. By condition, is the value of rear is equal to -1? No. So by condition as well, Q is not empty. So can we go to the second step? Yes. Increment the value of front by 1. That is front equal to front plus 1 mod size. So इससे front का value अगर 2 है तो फिर वो क्या होगा? No, not front plus plus, Ashwini. Not front plus plus. Front equal to front plus 1 mod size, right? And hence value of front becomes 3 now. Value of front becomes 3 now, right? It means we have deleted 33. Now I want to delete one more element from the queue. Again apply algorithm. Step number 1, check Q is not empty. So by diagram, is Q is empty? By diagram, is Q empty? No, by diagram, Q is not empty. So can we go to the second step? Yes, increment the value of front by 1. That is front equal to front plus 1 mod size. If we apply this expression, if value of front is 3, it will become 4. And hence, by means of incrementing value of front by 1, by using this expression, we have deleted one more element. So again, if I want to delete one more element, step number 1 is check Q is not empty. So is Q is empty by diagram? By diagram, is Q is empty? No, by diagram, Q is not empty. And hence by condition as well, is value of rear equal to -1? No. And hence Q is not empty. We can increment the value of front by 1 by this statement. Front equal to front plus 1 mod size. तो वो 4 का क्या होगा? 0 होगा. And hence 55 also gets deleted from the queue. Hello friends, are you getting what I'm saying? Sir, can we delete one more element similarly? Yes, we can delete one more element similarly. Sir, can we delete one more element similarly? Yes, because by diagram, is Q is empty? No, by diagram, Q is not empty, right? And hence we can go to the second step, increment the value of front by 1, right? And we have deleted one more element from the queue, right? Now, if we want to delete one more element from the queue, guys, pay attention. If we want to delete one more element, by diagram, is Q is empty? By diagram, is Q is empty? Yes. Sir, by condition, is the value of rear is equal to -1? No, it means condition fails. Condition fails. Hello friends, are you with me? यहाँ पे condition fail हो रहा है, right? And hence हमें क्या करना पड़ेगा? हमें यहाँ पे change करना पड़ेगा. Sir, क्या change करना पड़ेगा? Pay attention. Pay attention. Let me go one step behind. Let me go one step behind. Pay attention, guys. Now, if value of front and rear are what? Front and rear का value क्या है अभी? Hello friends, please reply me. मैंने undo किया है. Undo मतलब मैंने वो delete element किया था वो फिर से undo किया है. So currently value of front and rear are 1 1, right? Sir, while deletion now, pay attention. While deleting element, sir इसका मतलब rear and front का value कभी -1 हो रहा है क्या? अरे हमने एक expression use किया ना ये, rear equal to rear plus 1 mod size, front equal to front plus 1 mod size, and due to this, values of front and rear will never become -1, right? Okay, and hence ये condition कभी satisfy होगा ही नहीं. And hence pay attention, हमें और एक logic यहाँ पे add करना है. Pay attention. While deleting element from the queue, if value of front and rear are equal, while deletion of element from the queue, if values of front and rear are equal, what it indicates? Hello friends, what it indicates? It indicates that we are deleting last element. Hello friends, are you getting what I'm saying? While deleting element from the queue, if values of front and rear are equal, it means we are deleting last element. तो सर अगर हम last element delete कर रहे हैं, if we are deleting last element, then don't you think instead of incrementing value of front by 1, why should not reinitialize value of front and rear by 1 or by -1, right? So in that case, instead of incrementing, what we can do here, we check if value of front is equal to rear. It means if we are deleting last element, then what to do? Reinitialize. Front is equal to rear is equal to -1, right? Else, सर इसका मतलब अगर हम element, अगर last element नहीं है तो ये जो पहले था वो कंटिन्यू करो. Hello friends, have you understood this? So सर इससे क्या होगा देखो, if we are deleting last element, instead of incrementing value of front by 1, दोनों का वैल्यू क्या करो? Reinitialize by -1. So यहाँ पे क्या होगा? Yes, front का वैल्यू -1, rear का वैल्यू -1, and this element got deleted. Now if we further try to delete element from the queue, yes, if you try to further delete element from the queue, condition gets checked. Yes, by diagram, is Q is empty? Yes, by diagram, Q is empty. By condition, is Q is empty? Yes, by condition as well, Q is empty. And hence, yes, this condition is working absolutely fine, right? और इसके साथ हम लोग और एक condition लिख सकते हैं, if front is equal to rear. So दोनों का value same है, value of both are same, as well as दोनों का value क्या है? -1 है, as well as the value of rear is दोनों का value is -1. Hello friends, so this is Q empty condition and this is Q full condition, and these are NQ and DQ operations. These are NQ and DQ operations in a circular queue. Hello guys, have you understood this? So linear queue के conditions अलग है, circular queue के conditions अलग है, और मैंने changes भी किए इसमें. तो ये कौन सा queue हुआ? This queue is referred as a circular queue in which we can reutilize vacant places. In which we can reutilize vacant places. I hope it is clear to all of you. Hello friends, have you understood algorithm? Right? So you can follow this algorithm for any case. अरे अगर आपको लग रहा है सर यहाँ पे ये होगा तो you can apply this algorithm for any case, for all possibilities. पेपर वर्क करके चेक करो कि ये algorithm वर्क हो रहा है कि नहीं. 100% गारंटी देता हूं मैं आपको ये वर्क होगा for all possibilities. Is that fine? Is that fine friends? Right? So ये कौन सा queue है? This is a circular queue. This is a circular queue. Right? And now here we are finished with, yes, here we are finished with queue data structure. Last point of queue data structure is applications of queue data structure. Applications of queue. Just a minute. Just give me 1 minute, guys. Let me start this. What are the applications of queue? Means we can add and delete values in only one queue. In only one queue means we can add and delete values in only one queue. What it means, Devidas? What do you mean by only one queue? In only queue. In only queue means we can add and delete values in only queue. आपका क्वेश्चन गलत है देविदास. Your question is wrong. Priority queue आपको सिर्फ जितना बताया उतना इंपॉर्टेंट है. Whatever I told you about priority queue, that is sufficient. Sir, if front is at 2 and I want to delete value which is at 4. अरे अभी देविदास, I told you for any possibility, जो भी मैंने यहाँ पे algorithm दिया है वो try करो, it will work 100% fine. Whatever you want to do, sir इस position पे ये होगा तो मुझे यहाँ पे delete करना है. You can try it on paper by following this algorithm. Have you understood this algorithm? देविदास, if front is at 2, okay, don't worry. अगर आपने पूछ ही लिया तो मैं आंसर देता हूँ आपको, right? If front is at 2, front यहाँ पे है, okay, and I want to delete value which is at 4. अरे कैसे होगा? Not possible, because you can delete element only from front end in a queue data structure. Devidas, is that fine? Your question is wrong. Logically, your question is wrong. अगर front का value 2 है तो हम second position से ही delete कर सकते हैं and not from 4, because queue is such a data structure from which we can delete element only from front end. Is that fine? हाँ, तो queue ये queue data structure का concept में बताया मैंने आपको already. Right, in queue, yes. Is that fine? Is that fine? Okay, now what are applications of queue? Pay attention. Applications of queue. Queue is used to implement. अरे पहले queue पढ़ो यार पवन. Don't worry, मैं आपको ट्री पढ़ाऊंगा. Don't worry. मैंने लेक्चर छोड़ा है क्या अभी तक? Have I left the lecture? Have I leave the lecture still? No. Don't worry. पहले सामने जो सीख रहे हैं वो सीखो यार. Right? Pay attention. Yes, applications of queue. First application, queue is used to implement operating system data structures like job queue, ready queue, message queue, waiting queue. आप लोगों ने operating system में पढ़ा होगा waiting queue, message queue, job queue, ready queue. So these are kernel data structures or these are OS data structures, and these data structures can be implemented by using queue data structure. Right? Then next application, queue is used to implement OS algorithms. आप लोगों ने ऑपरेटिंग सिस्टम में एल्गोरिथम भी पढ़े होंगे. फर्स्ट कम फर्स्ट सर्व, सीपीयू शेड्यूलिंग, देन प्रायोरिटी सीपीयू शेड्यूलिंग, देन फर्स्ट इन फर्स्ट आउट पेज रिप्लेसमेंट एल्गोरिथम, एक्सेट्रा एक्सेट्रा. These algorithms can be implemented by using which data structure? By using queue data structure. Hello friends, is this fine? So by using queue data structure, these algorithms can be implemented. Right? ये उसका application है. Then one more application, queue is used to implement an advanced data structure algorithms like BFS. So what do you mean by BFS? Breadth first search, traversal in tree and graph. तो सर stack मैंने आपको किसके लिए बताया था? Stack data structure is used to implement DFS, depth first search, and queue data structure is used for BFS. Stack के लिए DFS और for DFS stack can be used and for BFS queue can be used. Is that fine, guys? So please remember this from CCAT point of view. From CCAT point of view, इतना याद रखो. Is that fine to all of you? And here we are finished with queue data structure. Here we have finished with क्यू डेटा स्ट्रक्चर. अभी डाउट है किसी को कुछ? हेलो गाइस, सर प्लीज एक्सप्लेन व्हाट इज बाइनरी हीप. वेट, डू यू हैव एनी डाउट इन क्यू डेटा स्ट्रक्चर? No? Okay, very good. Is anyone having any doubt in queue data structure? Now we can move to the next data structure, that is tree. That is tree, right? Atharva is saying what about double-ended queue? Atharva, what you can see over here? ये क्या दिख रहा है आपको यहाँ पे? What is this? Atharva, what is this? It is double-ended queue only. It is double-ended queue only. So we have already covered about it. हमने इसके बारे में ऑलरेडी कवर किया है, राइट? बिलीव मी, इससे ज्यादा आपको सीकैट में कुछ नहीं पूछेंगे. वॉट एवर आई मेंशन ओवर हियर अबाउट डबल एंडेड क्यू इन सीकैट, इससे ज्यादा आपको कुछ नहीं पूछेंगे. इज दैट फाइन? सो डोंट वरी अबाउट इट. ओके, if you are interested to learn data structure at implementation level in much detail, in much depth, please guys, for your information, sunbeam का और एक data structure and algorithm, data structures and algorithm करके एक modular batch, modular course हमने launch किया है. So you can join that batch. If you want to learn data structure concepts in much detail with implementation everything, right? So एक batch launch हो रहा है, data structures and algorithms, right? You people can join that batch. कब से है आपको ग्रुप के ऊपर, आपके ग्रुप के ऊपर उसका इन्फॉर्मेशन पता चल जाएगा, डोंट वरी. और यू कैन जस्ट विजिट सनबीम साइट, वहां पे आपको मिल जाएगा इन्फॉर्मेशन, राइट? बट इन क्रैश कोर्स बैच इट इज नॉट पॉसिबल टू टीच यू विद इम्प्लीमेंटेशन एवरीथिंग, राइट? क्रैश कोर्स इज ओनली सीकैट ओरिएंटेड. So can we move to the next, guys? We are moving to the next data structure, that is tree. Yes. What do you think? What tree is? What do you think? What is tree? Yes, it is. It is a non-linear. It is a non-linear advanced data structure. It is a non-linear advanced data structure which is a collection of again logically related similar type of elements, yes, in which contains finite number of elements, or we can say which is a collection of logically related similar type of elements, right? Similar type of finite number of elements. Let me write that as well. Finite number of elements in which there is a first specially designated element is there, or we can say first specially designated element is there, right? Or we can say there is a first specially designated element referred as a root element, and remaining all elements are connected to the root element in a hierarchical manner. In which manner, guys? In a hierarchical manner, follows parent-child relationship. Hello friends, have you understood this? Follows parent-child relationship, right? Don't worry, we'll try to understand this definition with the help of diagram, right? Okay, same definition I've written over here. Can you see, guys? It is a non-linear. So if you look at the diagram, in diagram, can we say elements are there in a non-linear manner, or that is in a hierarchical manner? Hello friends, have you understood what do we mean by non-linear? So elements in a tree data structure are there in a non-linear manner, that is in a hierarchical manner, right? So it's a non-linear data structure which is a collection of finite number of. So what do you mean by finite? That is, we can count 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So can we count? Yes, we can count number of elements in it. It means finite number of logically related similar type of elements. A, B, C, D, all these are alphabets. Right? So these are logically related similar type of elements in which there is a first specially designated element. अरे इन element में वहां पे एक ऐसा element है which has a special designation referred as root element. Please check root node, or we can say root node, right? And remaining all elements are connected to it in a hierarchical manner. Follows parent-child relationship. So what do we mean by parent-child relationship? Please pay attention. So here we can say node A is a parent node of B, or we can say node B is a child node of A, or A is a parent node of C, C is a child node of A, or D is a child of A, sorry, yes, D is a child of A, is a parent of D, or C is a parent node of J, J is a child node of C. Hello friends, have you understood what do you mean by parent and child? Parent node and a child node, right? Parent node and child node. So parent node is also called as father, child node is also called as son, right? So there is a parent-child relationship between elements I, N. I is parent node, N is child node. I is a child of B, and so on. Hello friends, right? Then one more terminology. A is a grandparent of F. Why? Because as B is a parent of F and A is a parent of B, and hence A becomes grandparent of F. I hope you people understood this as well, right? So here we can say grandparent or grandfather, or we can say grandfather, right? Or here we can say grandchild node, or grandson. Hello friends, have you understood these terminologies? Right? Then there is one more terminology called as siblings. Siblings. So what do you mean by siblings? Child nodes of same parent, B, C, and D. So तीनों का parent कौन है? As parent node of B and C is same, and hence B, C, and D are, yes, siblings, right? So here I can say child nodes of same parent are called as yes, siblings, right? Then pay attention, guys, very important. So ancestors. So what do you mean by ancestors? All the nodes which can be accessible, all the nodes which are in the root, which are in the path from root node to that node are called as ancestors. Let me tell you with an example. Pay attention. What do you mean by ancestors? All the nodes which are in the path from root node to that node are called as its ancestors. Right? It means, pay attention. Let's say if you want to find ancestors of Q, all the nodes which are in the path from root node to that node, right? It means, sir, अगर हम root से start करेंगे, A, D, and M. A, D, and M are ancestors of which node? Are ancestors of Q. Hello friends, are you getting what I'm saying? So A, D, and M. Sir, कोई भी node उसका खुद का ancestor होता है क्या? Can any node be an ancestor of itself? No. And hence Q खुद का ancestor नहीं है. No, any node cannot be ancestor of itself, right? Only nodes which are in the path from root node till that node or to that node are called as its ancestors. So A, D, and M are ancestors of Q. Can you please tell me which are ancestors of P? P के ancestors A, C, and J. A, C, and J. उल्टा मत जाओ. From root node. JCA नहीं, ACJ. From root node to that node. Hello guys, are you getting what I'm saying? These are called as ancestors. So I hope you people have understood what do you mean by ancestors. Then next, descendants. Sir, what do you mean by descendants? All the nodes which can be accessible. Nodes which can be accessible or which can be accessible from that node. All the nodes which can be accessible from that node are called as its descendants. For example, so from node D, we can access L, M, and Q. From D, we can access L, M, and Q. So L, M, and Q are descendants of D. So which are descendants of C? CK descendants of C. J, K, and P. Very good. So from C, we can access J, K, and P. And hence J, K, and P are descendants of C. So which are the descendants of B? BK descendants. FINO. FB hai. FINO are descendants of B. Is that fine? Okay, now one more thing. Pay attention. Leaf node. So what do you mean by leaf node? Node which is not having any number of child node. Called as node which is not having any number of child node called as leaf node. Last node nahi. अरे ऐसा concept है, right? And what do you mean by non-leaf node? Non-leaf node which is having any number of child node, either one or any number of, right, child node is called as non-leaf node, right? Leaf node is also called as, yes, external node, also called as terminal node. Synonyms. Similarly, non-leaf nodes are also called as internal node, also called as non-terminal. Hello friends, have you understood this? leaf node and non-leaf node. So can you please tell me which nodes are the leaf nodes? F, N, O, P, K, L, and Q. These are the leaf nodes because these nodes are not having any number of child nodes, right? Whereas B, I, J, C, D, M, these are non-leaf nodes, and A is a root node. Hello friends, I hope you people have understood leaf node and non-leaf node, right? Then there is one more point is degree of a node, right? So what do you mean by degree of a node? Number of child nodes having that node, right? So please, can you please tell me guys, what is the degree of A? No adding of node nahi. Degree of a node is equal to number of child nodes. A का degree कितना है? Node A is having how many number of child nodes? Only 3. B, C, and D, and hence degree of A is 3. What can we say? N of A. N of A means what? What do you mean by N of A? Apra. What do you mean by N of A? I didn't understood your question. Quickly ask your doubt. मुझे आपका क्वेश्चन समझ में नहीं आया. What will be N to A? N to A. अरे N to A क्यों जा रहे हो आप? Why you are going N to A? Rather you supposed to come from A to N. मतलब A, B and I. These are called as its ancestors. No, उसे कुछ नहीं बोलेंगे. उसे हम लोग कुछ नहीं बोलेंगे. ऐसा कुछ कंसेप्ट ही नहीं है. Right? So we can start from root node and then A, B, I. So A, B, I are the ancestors of N as well as O. Is that fine? Sir, ये I, B, A ऐसा कुछ नहीं है. No, ऐसा कुछ भी concept नहीं है. Okay, so degree of a node is nothing but number of child nodes having that node. So can you please tell me what is the degree of A? What is the degree of A? Degree of A is 3. What is the degree of B? Degree of B is 2. What is the degree of F? 0. What is the degree of J? 1. Right? So I hope you people have understood degree of a node. Right? Then sir, what do you mean by degree of a tree? Degree of a tree is nothing but, yes, maximum degree of any node in a given tree is called as a degree of a tree. So which node having maximum degree, guys? In this tree, which node having maximum degree? Yes, node A is having degree 3, and hence we can say degree of this tree is 3. Degree of this tree is 3. Is that fine? Okay, then sir, can we write leaf node ka one more point over here? So node which is having degree 0. Node which is having degree 0 is called as leaf node. Hello friends, do you agree with this? Node which is having degree 0 called as leaf node. Whereas node which is having non-zero degree, non-zero degree is referred as, yes, non-leaf node. I hope you people have understood this as well with the help of degree. Is that fine? Okay, then so what do you mean by level of a node? Right? Level of any node is equal to level of its parent node plus 1. Level of any node is equal to level of its parent node plus 1. Right? So if we assume, pay attention, by assuming, अरे non-leaf क्या चाहिए? Repeat आपको. Non-leaf मतलब node which is having either 1 or 2 or any number of child. Hardik. So B is a non-leaf node. Why? Because it is having one child. Sir, can we say I is a non-leaf node? Yes, because it is having more than 0 childs, मतलब 2 number of childs. अगर किसी नोड को एक भी child होगा, so that node is referred as non-leaf node. Hardik, is that fine? Hardik, I'm waiting for your reply. Hardik, सो गए क्या? Have you understood what do you mean by non-leaf node? Okay, very good. So node which is having any number of child node, either 1 or 2 or 3 or 4, any number. Node which is having any number of child node, non-leaf node. About node having 0 number of child nodes, it means do not having any child, leaf node. Right? Okay. Now level of any node is equal to level of its parent node plus 1. Right? Now if we assume root node is at level 0, अभी ये हमारे assumption के ऊपर है, right? अगर आप root node level 0 के ऊपर consider करोगे, if we assume root node at level 0, then yes, B, C and D can be considered at next level number 1. Hello guys, are you getting what I'm saying? Then sir, what about their child nodes? Their child nodes will be at next level, that is level number 2. So their child nodes are at next level, that is level number 3. Are you there guys with me? Right? So level of any node is nothing but the level of its parent plus 1. If we assume root node is at level 0, then their child nodes are at next level, next level, next level, and so on. सर अगर हमने लेवल 1 से स्टार्ट किया तो 1 2 3 4 ऐसे आएगा. Is that fine? Is that fine? And hence here we can say level of a tree. Level of a tree. Rather tree को level नहीं होता है, right? Depth होता है. So depth of a tree is equal to maximum level. Maximum level of any maximum level in a tree. Maximum level of a node of any node in a given tree. In a given tree. वो क्या होता है? Tree का depth होता है. Right? It means if we assume level from 0, yes, तो सर इस ट्री का डेप्थ कितना है? ट्री का डेप्थ इज 3. starting with 0. Starting with 0, depth is 3. Starting with 1, depth is 4. As per the assumption, it may vary from book to book. It may vary from we can say programmer reference book to reference book, or we can say implementation may vary from programmer to programmer. Is that fine? तो इसे बोलते हैं depth of a tree, right? Okay. It means yes, can we say tree is a dynamic data structure? Tree is a dynamic data structure. It means tree can in a tree node can have any number of child nodes. Agree with this? Node can have any number of child nodes, either 1 or 2 or 3 or 4 or 5, any number of child nodes. And tree data structure can grow at any level. So इस level के ऊपर कुछ limitation है क्या? No, right? So here let me write as tree is a dynamic data structure. Dynamic data structure. So yes, any node can have any number of child nodes, and yes, it can grow at any level. It can grow at any level. Hello friends, right? It can grow at any level. But don't you think guys, if this is so, then operations and hence yes, operations, or due to which we can say operations, especially like addition, deletion and searching, especially these operations cannot be performed on it efficiently. Hello friends, do you agree with this? Sir, अगर ट्री डेटा स्ट्रक्चर, अगर एक नोड को कितने भी चाइल्ड नोड हो सकते हैं, if tree can grow till any level, don't you think this operation will not remain efficient? Right? And hence yes, to achieve efficiency on tree data structure, yes, few restrictions can be applied on it. Few restrictions can be applied on it, and hence there are yes, different types of tree. Hello friends, have you understood this point? Right? So tree data structure, as it is dynamic in nature, so it can grow at any level, and any node can have any number of child nodes. So due to this, operations like addition, deletion, searching becomes inefficient. So to perform these operations efficiently, the few restrictions can be applied on it, and hence there are different types of tree. उसमें से पहला है बाइनरी ट्री. अरे किसी ने क्वेश्चन पूछा था बीच में, सर ये बाइनरी ट्री क्या होता है? So binary tree, it is a type of tree. In which yes, each node can have either 1, either 0 or 1, or either 0 or 1 or two number of child nodes. So it is a type of tree in which each node can have either 0 or 1 or two number of child nodes. Hello friends, are you getting what I'm saying? It means in a binary tree, degree of any node is either 0 or 1 or 2, not more than 2. So maximum, each node can have maximum degree 2. I hope you people have understood binary tree. Okay, let me show you diagrammatically. Guys, pay attention. Okay, can you please tell me, is this a binary tree? Whatever diagram you can see in front of you, is this a binary tree? No. So why this is not a binary tree? Because node A is having how many number of child nodes? 3 number of child nodes. and hence this is not a binary tree. So, but is this a binary tree? Yes, this is a binary tree, because if you see, so node A degree 2, so node B का degree 2, node D का degree 1, node G का degree 1, degree of K is 0, degree of H is 0, degree of E is 1, degree of C is 2, right? You can take any node. Degree of any node is either 0 or 1 or 2. Hello friends, have you understood this? And hence it is what called as a binary tree. It is what called as a binary tree. Sir, binary tree ka definition we can write in other way around as well. In other words as well, we can say definition of binary tree. Pay attention. Binary tree is a set of finite number of elements having three subsets. Having three subsets. Right? Okay, so which three subsets? Number one, root element. Sir, can we have only one element in a set? Set theory, mathematics, 11 science. 11 science ka mathematics, set theory. Can we have only one element in a set? Yes. Such a set is called as singleton set. Sir, can we have zero number of element in a set? Can we have zero number of element in a set? Yes. Such a set is referred as empty set or null set. उसे आप लोग either empty set बोलते हैं या तो null set बोलते हो. And sir, can we have more than one number of elements? Yes, obviously. हो सकते हैं, right? It means here we can say binary tree. It is a set of finite number of elements having three subsets. Subset number one, root element. Root element, right? Then left subtree. Left subtree, it may be empty, maybe non-empty. So अभी ये empty है क्या? No, it is not empty. It is what referred as the left subtree. And right subtree. This is a right subtree. Right? Now, sir, why it is referred as the left subtree and right subtree? Because again, this is itself is a binary tree. अरे ये तो subtree है, it is itself is a binary tree in which this can be a root. Yeah, recursively, this can be a root. Sir, ये क्या है इसका? It is a left subtree of B and it is right subtree of B. Hello friends, are you with me? Sir, again, why it is referred as left subtree? Because again, in this left subtree, D can be a root, G can be its left subtree, and its right subtree is empty. Right subtree may be empty, right? So, sir, in this right subtree, C can be a root. This is a left subtree, and this is a right subtree of C. So again, why we can refer to the right subtree? Because again, F can be a root, which is having empty left subtree, empty right subtree. Recursively, it can be a binary tree. Hello friends, have you understood this definition? आपको ये definition समझ में आया क्या binary tree का? Have you understood concept of binary tree? Right? Okay. Now further restriction can be applied. Further restriction can be applied on binary tree, right? And binary search tree can come to the picture. Binary search tree. Sir, what do you mean by binary search tree? It is a type of tree, or it is a binary tree first. It is a binary tree. अरे इसका मतलब ये binary tree होना चाहिए. It is a binary tree. It is a binary tree in which left child. अरे obviously अगर वो binary tree है तो maximum it has how many number of child nodes? If it is a binary tree, maximum it has how many number of child nodes? 2, right? So can we say left child and right child? Can we say left child and right child? Yes, we can say left child and right child. So binary search tree, it is a binary tree in which left child is always, yes, always smaller than its parent, whereas right child is always, or we can say whereas the and right child is always, yes, right child is always greater or equal to its parent. Hello friends, right? So what do you mean by binary binary search tree? Binary search tree, it is a binary tree in which left child is always smaller than its parent and right child is always greater than or equal to its parent, right? So if I show you diagrammatically, hello friends, can you see this diagram? Can you see this diagram? So in this diagram, sir, is this a binary search tree? Yes, this is a binary search tree. Please check. Root node का, अरे root node 50 क्यों है? Because it's a first. अरे पहले देखो यहाँ पे 50, इसलिए 50 is the root node, first node, right? Then if you can see, left child is always smaller than its parent. 10 is a left child of 20, it is smaller than 20. Please check, you can see, you can apply this property. Left child is always smaller than its parent and right child is always greater than or equal to its parent. You can see over here. Hello friends. Have you understood binary search tree? आपको binary search tree समझ में आया क्या guys? So binary search tree is a type of, it is a binary tree in which, yes, it is a binary tree in which left child is always smaller than its parent and right child is always greater or equal to its parent, right? Okay, now we'll see tree traversal methods. Pay attention. Arey, ye tree reduction hai, right? Now we see tree traversal methods which are important from your CCAT point of view. So what do we mean by traversal? What do we mean by traversal? Tree traversal. To visit each node maximum once, right? To visit each node maximum once. So there are, yes, there are three ways, or there are three tree traversal methods. There are three tree traversal methods. Sir, which three? Number one is pre-order. Number one is pre-order. Number two is in order. And number three is post-order. Post-order, right? Now for pre-order, please remember the formula, guys. Remember the formula for pre-order. Yes, pre. First visit that node, then visit left child, sorry, left subtree, and then visit right subtree. So V is before LNR, right? Then for in order, yes, left visit right, and for post order, yes, left right visit, right? It means so इसका मतलब क्या देखो, we can always start traversal from which node? अरे for any traversal we can start traversal from root node. Very good, from root node, right? So आप कौन सा भी traversal लो, for all type of traversal we can start traversal from root node, right? Now once we start traversal, yes, in pre-order traversal, yes, first visit that node. तो सर हम पहले विजिट क्या करेंगे? First we'll visit 50. First we need to visit this node. Hello friends, are you with me? First we need to visit this node, right? Now after visiting this node, go to visit its left subtree first. After visiting this node, go to visit its left subtree. Sir, is 50 is having left subtree? Yes, go to its left subtree. So don't you think we reach to 20? So whenever we reach to any node, first visit that node. So 50 के बाद क्या विजिट करना है? 20, right? Again, after visit, is 20 is having left subtree? Is 20 is having left subtree? Yes, 20 is having left subtree. Go to visit its left subtree first, and hence we go to its left subtree, right? Then visit 10. So 10 visit करने के बाद again is 10 is having left subtree? Yes, go to visit its left subtree first, and hence when we reach to any node, first visit that node. Now after visiting 5, is a 5 is having left subtree? No. Then check, is a 5 having right subtree? No, 5 is not having right subtree as well. Go to its parent. Again check, sir, 10 ka left subtree already visited. Then is a 10 is having right subtree? Yes, go to its right subtree. And first visit 15. Then after visiting 15, check, is a 15 is having left subtree? No. Is 15 having right subtree? No. Go to its parent. Sir, 10 ka right subtree already visited. Go to its parent. 20 ka left subtree already visited. Then check, is 20 is having right subtree? Yes. Go to its right subtree. Right? Then first visit 45. After visiting in the node V के बाद L. Sir, V को L है क्या? 45 is having left subtree? Yes. Go to its left subtree. Again first visit 30. Is 30 is having L? No. Is 30 is having R? No. Right? Go to its parent. Sir, 50 ka L already visited. Sorry, 45 ka L already visited. Sir, is a 45 is having R? Right subtree? No. Go to its parent. Sir, 20 ka L as well as R both are visited. 20 ka L as well as R both are visited. Hence go to its parent. Sir, 50 ka L left subtree already visited. Is a 50 is having right subtree? Yes, and hence go to visit its right subtree. First visit 90. Then V के बाद L ना, is 90 is having L? Yes, go to its L. Visit 85. Again, please visiting any node, please check, is it having L? Yes, go to its L. Visit 75. After visit, is it having L? Yes, go to its L. Visit 50. This 50 and this 50, these two are different elements. ये फिजिकली दो अलग अलग नोड्स, अलग अलग एलिमेंट्स है, दोनों का सिर्फ की वैल्यू सेम है, 50-50 की वैल्यू सेम, राइट? सो 50 विजिट करो. सर, इज दिस 50 इज हैविंग L? नो. इज दिस 50 इज हैविंग R? नो. गो टू इट्स पेरेंट. सर, 75 L ऑलरेडी विजिटेड, do not having R, go to its parent. Again 85 ka L already visited, is this having R? No. Go to its parent. Sir, 90 ka L already visited, is this node having R? Yes. Go to its right subtree. Yes. Visit 100 first. After visiting any node, is 100 is having L? Yes. Go to its L. Go to its left subtree. Visit it. 95. After visiting 95, is 95 is having L? No. Is 95 having R? No. Go to its parent. Is 100 is having R? Yes. Go to its R. Visit it 120. So this is which traversal? अरे कौन सा traversal हुआ ये? This is pre-order traversal. So please remember one point. In pre-order traversal, root node always gets visited first. In pre-order traversal, root node gets always visited first, right? And it remains applicable recursively for every subtree as well. So इसका मतलब please check. Sir, इस subtree का root कौन है? Who is the root of this subtree? 90, right? So 90 will get visited before these nodes. Please check. देखो 90 यहाँ पे देखो 90 इन nodes के पहले विजिट हुआ है. So root node always gets visited first and it remains applicable recursively for every subtree as well, right? So in this subtree, pay attention guys. In this subtree, can you please tell me? In this subtree, can you please tell me which is the root? 100 is the root, right? So 100 gets visited first before 95 and 120. 95 120 के पहले 100 विजिट हुआ है. Hello guys, have you understood this property? आपको ये property समझ में आएगा प्री ऑर्डर का, right? Now we are moving to the in order traversal. Sir, in order traversal, yes, left visit right. It means we can visit any node only after visiting its left subtree. We can visit any node only after visiting its left subtree or its left subtree is empty, right? Okay, we can always start traversal from which node? We can always start traversal from which node? Root node. Sir, do you need to visit this node or can we visit this node? No, because first we have to visit its left subtree. So is this node having L? Yes, go to its L. Again, sir, can we visit 20? No, because first check is 20 is having L. Yes, go to its L. Again, is 10 is having L. Yes, go to its L. Again, please check is 5 is having left subtree. No. So can we visit 5 now? Yes, we can visit 5. We can visit 5. Then after visit R na is a 5 is having R. No, and hence go to its parent. Sir, 10 ka L already. 10 ka left subtree already visited. So can we visit this node now? Yes, we can visit any node. We can visit any node. Either its left subtree is already visited or empty. Sir, 10 ka L already visited. Now we can visit 10. Sir, V ke baad R. Is 10 is having R? Yes, go to its R. Again check is 15 is having L? No. Now can we visit 15? Yes, because its left subtree is empty. After visit 15 is having R. अरे इसको R है क्या? इसको R है क्या? No, it is not having R, and hence go to its parent. Again 10 का L as well as R both are visited. Go to its parent. Go to its parent. So 20 is its L is already visited. 20 का L visit हुआ क्या? Yes, and hence now we can visit 20. Now we can visit 20, right? Now after visiting 20, yes, is this not having R? Yes, go to its R. 45. Whenever we come to any node, first check is a 45 is having L. Yes, go to its L. Is 30 is having L? No, 30 is not having L. So can we visit 30? Yes, we can visit 30 because we can visit any node only after its left subtree is either empty or already visited. तो हम लोग यहाँ पे 30 visit करेंगे पहले, right? 30 visit करने के बाद is 30 is having R? No, 30 is not having R. Go to its parent. So 45 का L already visited. Now we can visit 45. Now we can visit 45, right? Because we can visit any node either its left subtree is empty or its left subtree is already visited. Now after visiting 45, check is 45 having R? No, go to its parent. So 20 का right subtree visited. Go to its parent. 50 का left subtree visited. Can we visit 50? Yes, we can visit 50 now. After visiting 50, yes, go to R na, V ke baad R. Go to its R. Is this not having L? Yes, go to its L. Is this not having L? Yes, go to its L. Is this not having L? Yes, go to its L. Sir, is this 50 having left subtree? No. So can we visit 50? Yes, we can visit this 50. Sir, is this node having R? No, go to its parent. So 75 ka L already visited and hence we can visit 75. Sir, is 75 is having R? No, go to its parent. Sir, 85 ka left subtree already visited. So can we visit 85? Yes, we can visit 85. After V, is 85 is having R? No, go to its parent. Sir, 90 ka L already visited. So can we V LV? Yes, visit it. After visiting 90 R, V R na, is this having right subtree? Yes, go to its right subtree. Again 100, is this 100 having left subtree? Yes. So without visiting 100, go to its left subtree first. 95, is 95 having left subtree? No. So can we visit 95? Yes, we can visit 95. Sir, is 95 having right subtree? No, go to its parent. 100, can we visit 100? Yes, because its left subtree already visited. Now we can visit 100. Is 100 having right subtree? Yes, go to its right subtree. Then check, is 120 having left subtree? No. Sir, can we visit 120? Yes, we can visit 120. We can visit 120. right? And here we have finished with in-order traversal. So in in-order traversal, remember one thing: all nodes gets visited in ascending order. All nodes gets visited in an ascending order. Please check. Sorted manner में आपको ये क्या होंगे विजिट होंगे in a sorted manner and in ascending order, right? Now last traversal method, post order traversal. We can always start traversal from root node. इसने क्वेश्चन पूछा था बीच में, सर कैन वी स्टार्ट ट्रैवर्सल फ्रॉम 5? नो, वी कैन ऑलवेज स्टार्ट ट्रैवर्सल फ्रॉम रूट नोड इन अ ट्री. हम ऐसे बीच में कहीं से भी ट्रैवर्सल स्टार्ट कर सकते हैं क्या? नो, नॉट पॉसिबल. वी कैन स्टार्ट ट्रैवर्सल ओनली फ्रॉम, लेट मी राइट ओवर हियर, ओनली फ्रॉम रूट नोड. प्लीज रिमेंबर दिस पॉइंट, राइट? तो सर ट्रैवर्सल स्टार्ट कहां से करेंगे? वी कैन स्टार्ट ट्रैवर्सल फ्रॉम रूट नोड. व्हाट इज द फॉर्मूला? LRV. इट मींस वी विल गोइंग टू विजिट, वी कैन विजिट एनी नोड only after visiting its left subtree as well as right subtree or they are empty. मतलब लेफ्ट सबट्री राइट सबट्री दोनों विजिट करेंगे और अगर एम्प्टी होंगे देन ओनली वी कैन विजिट एनी नोड, राइट? ओके, सो वी स्टार्ट ट्रांसफर फ्रॉम रूट नोड. 50 से स्टार्ट करेंगे. इज 50 इज हैविंग L? यस, गो टू इट्स L. इज 20 इज हैविंग L? यस, गो टू इट्स L. इज 10 हैविंग L? यस, गो टू इट्स L. सर इज 5 हैविंग L? नो. सर कैन विजिट 5? नो. फर्स्ट चेक, इज 5 हैविंग R? Is 5 having R? No, 5 is not having R, and hence 5 is not having L as well as R. Now we can say we can visit 5. We can visit 5. Now we can go to its parent. Sir, 10 ka L already visited. Sir, can we visit 10? No, because 10 is having R. So without visiting its R, we cannot visit its 10. We can visit its node, and hence is it having R? Yes. So go to visit its R first. उसका पहला R visit करो. Go to R, right subtree. Then is 15 is having L? No. Is 15 having R? No. So we can visit 15. After visiting 15, go to its parent. Sir, 10 ka L as well as R both are visited, and hence now we can visit 10. We can visit any node either if either its left subtree and right subtree are empty or already visited. So after visiting 10, go to its parent. Sir, 20 ka left subtree already visited. Is 20 having right subtree? Yes, and hence go to visit it first. 45 is 45 is having L? Yes, go to visit its left subtree first. Again, is 20 having L? No. Check, is 30 having R? No, and hence we can visit 30 because it's L and R empty. Go to its parent. 45. So 45 ka L already visited. 45 is it having R? No, and hence its L is already visited, R is empty. We can visit 45. Go to its parent. So 20 ka L as well as R both are visited, and hence we can visit 20. Go to its parent. Sir, can we visit 50? No, because it's only L is visited. Is this node having R? Yes, and hence first visit its right subtree first, and then only we can visit that node. So go to its right. 90. Again, is this node having L? Yes, go to L. Is this node having L? Yes, go to L. Is this node having L? Go to L. Is this node having L? Go to L. No, इसको L नहीं है. So it is not having L. So is this node having right? No, and hence we can visit 50. Then go to its parent. So 75 L already visited, do not having R, and hence we can visit 75. Go to its parent. 85 L already visited, do not having R, we can visit 85. Go to its parent. 90 L is already visited. Is 90 is having R? Yes, go to its R. Is 100 having L? Yes, go to its L. Is 95 having L? No. Is 95 having R? No. So we can visit 95. Then go to its parent. 100 ka left subtree already visited. Is 100 having right subtree? Yes, go to its right subtree first. 120, is it having L? No. Is it having R? No, and hence we can visit 120. Then we can go to its parent. Sir, can we visit 100? Yes, because 100 ka L and R already visited. Go to its parent. 90 ka L as well as R both are visited. We can visit 90. Go to its parent. 50 ka L as well as R both are visited. Go to its parent. So one more point to be noted. Pay attention. In pre-order traversal, root node always gets visited first, right? Whereas in post-order traversal, root node always gets visited at last, and this property remains applicable same recursively for every subtree as well. For example, pay attention. For example, can we say this is a subtree? Yes. So sir, is subtree का root कौन है? Root node always gets visited at last, at the end. Sir, 10, 5 and 15, right? So therefore 10 gets visited after 5 and 15. So root node always gets visited at last. Hello friends, so this property remains same recursively for every subtree. So have you understood these three traversal methods? अरे आपको ये traversal method समझ में आया क्या? Right? And here we are finished with everything, right? Okay, now let me tell you one more point, guys. आप लोग बाकी की चीजें पढ़ सकते हो खुद से, and for any kind of doubts, you people can either ask me onto the WhatsApp group आपके डाउट्स अगर होंगे तो व्हाट्सएप ग्रुप पे पूछो, राइट? और यू पीपल कैन आस्क मी ऑन टू द जूम चैनल. इज दैट फाइन गाइस? Okay, binary heap. Let me tell you very quickly. What do you mean by binary heap? Binary heap is a binary tree only. It is a binary tree in which binary heap is a binary tree only, right? Binary heap is a binary tree in which, yes, usually all leaf nodes are at last level. It is a binary tree in which usually all leaf nodes are at last level and, yes, are arranged as left as possible. So it is what called as binary heap. So what do you mean by binary heap? Binary heap is a binary tree in which usually all leaf nodes are at last level and are arranged as left as possible. Hello friends, is this clear to all of you? Okay, let me show you this with our diagram. एक मिनट, मैं आपको विद डायग्राम दिखाता हूँ. यहाँ पे डायग्राम दिख रहा है सबको गाइस? This diagram. Can you see this diagram, right? So in this diagram, usually all leaf nodes, please check 5, 9, 8. These leaf nodes are at, yes, are at last level. मैंने यहाँ पे लिखा देखो, are at last level and are arranged as left as possible. देखो as left as possible arrange हुए वो, right? And this binary tree, this complete binary tree, इसे complete binary tree बोलते हैं, right? इसी को बोलते हैं complete binary tree. So complete binary tree is nothing but a binary heap. Complete binary tree is nothing but a binary heap because this tree can be represented by using array as well. Please check. अरे देखो ये array representation भी कर सकते हैं हम लोग. Either you can draw like this or you can have array representation in which we can use this formula. अरे हम लोग ये formula use करेंगे. Whereas ARR of 0 is a root node. ARR of 0 is a root node. उसके बाद अगर इसके बाद अगर आपको लेफ्ट चाइल्ड, राइट चाइल्ड एंड पेरेंट निकालना है किसी का, तो मैंने यहाँ पे फॉर्मूला आपको लिख के दिया है. आई विल शेयर दिस विथ यू, राइट? सो एरर ऑफ 0 इज कंसीडर्ड एज रूट नोड. उसके बाद अगर आपको बाकी के नोड्स एक्सेस करने हैं, सो वी कैन यूज दिस फॉर्मूलाज टू एक्सेस द नोड्स. दिस इज व्हाट कॉल्ड एज बाइनरी हीप. अपरा, इज दिस क्लियर नाउ? डोंट वरी, आई विल शेयर दिस विथ यू. तो इसी को बोलते हैं बाइनरी हीप. सो बाइनरी हीप इज नथिंग बट अ कंप्लीट बाइनरी ट्री. Right? Okay, now we have almost extended lecture around 1 hour and 10 minutes, right? So I'm having another lecture now at 3:30, right? So we cannot extend further. So अगर आपको कुछ doubts होंगे guys, it's a request to all of you. अगर कुछ doubts होंगे, so you people can ask your doubts onto the WhatsApp group or onto the Zoom channel. I will reply answers to your questions. So can we stop over here guys? Yes, don't worry. आज के doubts आपको, sorry, आज के में share हो जाएंगे, don't worry. हाँ, लेकिन वो कब होंगे? By the day, by end of day. By end of day मैं आपको ये शेयर करूंगा. Is that fine? Don't worry about it. Because I'm having lecture right now at 3:30, right? I need to take lunch and then go for the next lecture. Don't worry, I will share this data with you by end of day. Don't worry, right? Thank you very much. Thank you, Pawan. We'll stop over here. All the best for your CCAT exam. For any kind of doubts, you can feel free to ask me on the WhatsApp group. On the WhatsApp group, my number is there. Either you can ask your doubts onto the group or you can ask me personally.